Hello friends, now we will discuss about a very important concept of ionic bond or electrovalent bond, which is Born-Haber cycle. Now what is Born-Haber cycle? Born-Haber cycle is a cycle which correlates between lattice energy with other thermodynamic functions. It is based on Hess's law. So Born-Haber cycle is a cycle which correlates between lattice energy with other thermodynamic functions, and it is based on Hess's law. What is lattice energy? Lattice energy is represented by U, 0. Lattice energy is equal to minus A into modulus of Z plus into modulus of Z minus by R0 into 1 minus 1 by N. Actually, the definition of lattice energy is that the amount of energy released when 1 gram formula weight of an ionic solid is formed, 1 gram formula weight of an ionic solid is formed from required number of cation and anion is called lattice energy of that ionic solid. Now, this A is called Madelung constant. It is a constant. It is called Madelung constant. R0 is equilibrium distance between cation and anion. Z plus modulus of charge of cation Z minus charge of anion R0 distance between cation and anion. N is a constant quantity called Born exponent. Born exponent. So this is the formulation of lattice energy. Now how Born-Haber cycle correlates between lattice energy with other thermodynamic function, we will discuss about that. Let us consider an ionic solid, sodium fluoride. Now sodium fluoride is formed like that. Sodium solid reacts with fluorine gas, half molecules of fluorine. As a result, sodium fluoride NaF is formed. It is solid, and the energy released during this process is called enthalpy of formation. It is represented by delta HF. Now, if we consider the process in details, there will be large number of small steps. First of all, sodium solid is converted to sodium gas, and the energy required for this process is delta H sublimation. The conversion of process from solid to gas is called sublimation, and the energy required is called delta H sublimation. And in case of fluorine, is converted to fluorine atom by breaking the bond between two fluorine atoms, and the energy required is called enthalpy of dissociation. Now, if complete dissociation of F2 occurs, two fluorine atoms are formed, only half amount of energy is required. So, to convert F2 molecule into one fluorine atom, half of dissociation energy is required. After that, sodium gas is converted to sodium ion in gaseous form, and the energy required is called delta H ionization energy, enthalpy of ionization. And fluorine atom is converted to fluoride ion with the help of electron gain enthalpy. This is represented by delta Ag, as a result of which F minus ions are formed in gaseous form. Now, these Na plus and fluoride ion together combine to form NaF. And when Na plus and F minus come close together, sodium fluoride lattice is formed. That is an ionic solid having a definite geometry, and the energy released is called enthalpy lattice energy, which is delta HU. Now, Hess's law states that if a process occurs in one step, in single step, that is from sodium and fluorine, half fluorine molecule gives sodium fluoride, which is delta HF, but the process actually occurs in several number of steps. And different types of energy are required: sublimation energy, dissociation energy, ionization energy, electron gain enthalpy, lattice energy, etc., etc. Then in both cases, the enthalpy change will be same. This is Hess's law. This means that delta HF is equal to delta HS plus half of delta HD plus delta HIE plus delta HEG plus delta HU. Now, if we know all the enthalpy terms, that is delta HF, delta HS, delta HD, delta HIE, delta EG, then we can calculate delta HU. So, Born-Haber cycle correlates delta HU with other thermodynamic functions like sublimation energy, dissociation energy, ionization energy, electron gain enthalpy, enthalpy of formation, etc., etc. This is Born-Haber cycle. Now let us consider with a physical example. Let ionization energy of sodium is 200 kilojoule mole inverse. Electron gain enthalpy of fluorine is minus 50 kilojoule mole inverse. Sublimation energy of sodium is 100 kilojoule mole inverse. Dissociation energy of fluorine is 60 kilojoule mole inverse. Enthalpy of formation of sodium fluoride NaF is delta HF, and it is equal to minus 300 kilojoule mole inverse. We have to find what is the lattice energy for NaCl. Lattice energy for NaF, that is U. Now, according to Hess's law, delta HF equal to delta H sublimation of sodium plus half into delta H dissociation of fluorine plus delta H ionization energy of sodium plus delta H electron gain enthalpy of fluorine plus delta HU of, that is lattice energy of NaF. Now delta HF is 200, delta HS is 100, delta H dissociation of fluorine is 60 and its half is 30. Delta H ionization energy for sodium is 200, and delta H electron gain enthalpy for fluorine is minus 50, and we don't know what is lattice energy of sodium fluoride. It is delta HU. Wrong. value is written. It is not 200. The delta H formation of sodium fluoride is minus 300. If we calculate this, delta HU can be calculated like that. It is minus 300 minus 100 minus 30 minus 200 plus 50, and the value is minus 400 minus 430 minus 630 plus 50, that is minus 630 plus 50, that is minus 580 kilojoule mole inverse. Let us check another time. Minus 300 minus 400 minus 430 minus 630 plus 50, that is 580 kilojoule mole inverse. That's all. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.